What if I told you that creating the perfect bottle of Heinz ketchup requires more engineering precision than building a smartphone? Every day, Heinz facilities process over 2 million pounds of tomatoes through a manufacturing system so complex that a single miscalculation could ruin an entire batch worth hundreds of thousands of dollars. From the moment those red tomatoes enter the factory gates to when that familiar bottle reaches your table, there's a hidden world of industrial precision that most people never get to see. Most people think tomatoes are just tomatoes, but Heinz rejects 40% of potential suppliers before they even plant a single seed. The company operates what amounts to an agricultural intelligence network that spans continents, searching for farms that can meet requirements so specific that most growers never even qualify for consideration. Heinz scouts tomato farms across carefully selected regions worldwide, focusing primarily on California's Central Valley, parts of Ohio, and Mediterranean climate zones in Europe. These areas share similar characteristics that make them suitable for ketchup production. The company's agricultural teams spend months evaluating potential farming locations, studying everything from rainfall patterns to soil drainage capabilities. Each region must demonstrate consistent weather patterns over multiple growing seasons before Heinz considers establishing contracts there. The soil composition requirements eliminate most farms from consideration immediately. Heinz demands soil with specific pH levels between 6.0 and 6.8, along with precise mineral content ratios. The dirt must contain exact amounts of potassium, phosphorus, and nitrogen while maintaining proper drainage to prevent waterlogged roots. Farms located near industrial areas or major highways get automatically rejected due to potential contamination concerns. Even the slope of the land matters, as fields with improper drainage angles can produce tomatoes with inconsistent water content. The testing process involves Heinz agronomists analyzing sugar content, acidity levels, and pectin density in sample crops from potential suppliers. Teams collect soil samples every 50 feet across proposed farming areas, testing for heavy metals, pesticide residues, and organic matter content. They measure the Brix levels in tomatoes, which indicates sugar concentration, requiring readings between 4.5 and 5.2 degrees. The acidity must fall within a narrow range of 4.2 to 4.6 pH to ensure proper preservation during processing. Farms must pass a 2-year trial period where every harvest gets laboratory analysis for consistency. During this probationary phase, Heinz technicians visit farms monthly to monitor growing practices and collect samples. Each delivery gets tested for soluble solids, color intensity using Hunter lab measurements, and viscosity potential. Farmers receive detailed reports showing how their tomatoes compare to Heinz standards, with specific recommendations for improving crop quality. The contract farming system provides approved growers with specific seed varieties developed exclusively for Heinz production. These seeds produce tomatoes with thicker walls, lower moisture content, and higher pectin levels than standard varieties. Farmers must follow detailed planting schedules, irrigation guidelines, and fertilization programs provided by Heinz agricultural specialists. The company monitors satellite imagery of contracted fields to ensure compliance with spacing requirements and growth patterns. Harvest timing. Precision requires tomatoes picked within a 48-hour window when sugar and acid levels peak. Farmers use refractometers to test sugar content daily as harvest approaches, waiting for the exact moment when readings hit target levels. Tomatoes picked even 1 day too early contain insufficient sugars, while those harvested late develop excessive moisture that dilutes flavor concentration during processing. The financial stakes create enormous pressure for farmers who fail to meet Heinz's standards. A rejected harvest can cost growers tens of thousands of dollars, as Heinz tomatoes cannot be easily sold to other buyers due to their specialized characteristics. Some farmers invest over $500,000 in equipment and infrastructure modifications to meet Heinz requirements, making contract loss financially devastating. Only farms meeting 47 different quality metrics earn the right to supply Heinz factories. These measurements cover everything from pesticide residue levels to seed cavity ratios within individual tomatoes. The approval process typically takes 3 years and costs farms an average of $200,000 in testing and compliance expenses. Once approved, suppliers undergo annual recertification to maintain their contracts. These carefully selected tomatoes now face an even more demanding gauntlet at the factory gates. The moment trucks arrive at Heinz facilities, every tomato faces a 90-second inspection process that determines its fate. Drivers back their vehicles up to massive receiving bays where hydraulic systems tip entire truck beds, sending tons of tomatoes cascading onto steel conveyor systems. These receiving areas can handle up to 60 trucks simultaneously during peak harvest season, with each truck carrying between 25 to 30 tons of fruit. The massive receiving bays feature water-filled channels that catch the tumbling tomatoes, cushioning their fall to prevent bruising. Powerful air bubble systems massage the fruit during this initial soak, gently removing field dirt while protecting the delicate skins. Workers monitor each incoming load, checking delivery paperwork against quality certificates issued by farm inspectors. Any truck arriving outside its scheduled time window gets redirected to holding areas where samples undergo additional testing. High-speed optical scanners photograph each tomato 40 times per second as fruit moves along inspection conveyors. These scanners detect color variations, surface blemishes, and size irregularities using laser technology that measures dimensions to within millimeters. Computer systems analyze these images instantly, triggering air jets that blast defective tomatoes off the main conveyor line. The rejection rate during peak processing can reach 15% of incoming fruit, with bruised or underripe tomatoes diverted to animal feed processing. The washing systems use chlorinated water baths maintained at precisely 3 parts per million chlorine concentration. Rotating drums tumble tomatoes through these sanitizing baths for exactly 90 seconds, ensuring complete surface contact while mechanical brushes scrub away stubborn debris. High-pressure water jets operating at 40 pounds per square inch blast each tomato clean as it exits the washing drums. Temperature-controlled rinse stations remove chlorine residue using filtered water heated to 65 degrees Fahrenheit. Giant stainless steel rollers process 50,000 pounds of tomatoes per hour through the crushing machinery. These rollers apply graduated pressure, starting gentle to crack the skin and increasing force to extract maximum juice without crushing seeds. Vibrating screens separate pulp from juice immediately after crushing, with different screen sizes creating varying texture grades for different product lines. The crushed tomato mixture flows directly into holding tanks that prevent oxidation through nitrogen gas injection. The cooking process takes place in enormous kettles reaching 200 degrees Fahrenheit, where natural pectins activate to create the characteristic thickness. Steam injection systems heat the tomato mixture evenly, while automated stirring mechanisms prevent hotspots that could scorch the product. These kettles hold up to 8,000 gallons of tomato mixture, with cooking cycles lasting exactly 45 minutes for optimal pectin activation. Vacuum concentration systems remove excess water while preserving volatile flavor compounds that give ketchup its distinctive taste. Steam injection and vacuum concentration operates at precisely controlled pressure levels, removing moisture without damaging delicate flavor molecules. Temperature sensors monitor the mixture every 30 seconds, automatically adjusting heat levels to maintain consistent processing conditions. Vacuum chambers operate at 15 inches of mercury, concentrating the tomato solids from 6% to 28% while preserving essential nutrients. Continuous monitoring systems track temperature, pressure, and cooking time across 47 different measurement points to prevent batch failures. Digital sensors feed data to central computers that can detect problems within 15 seconds of occurrence. Quality control technicians sample the cooking mixture every 10 minutes, testing for proper consistency and flavor development using calibrated instruments. This industrial precision transforms raw tomatoes into consistent puree within 45 minutes, converting truckloads of fresh fruit into the standardized base ingredient that forms ketchup's foundation. This perfectly prepared puree now enters the most secretive part of the entire operation. Hidden behind unmarked doors, Heinz's master blenders guard a recipe formula that only 12 people in the world know completely. These individuals work in climate-controlled blending rooms where security cameras monitor every movement and access requires special clearance badges. The recipe itself gets stored in multiple locations, with no single person having access to all components simultaneously. This level of secrecy protects a formula that generates billions in revenue annually. The climate-controlled blending rooms maintain precise temperature and humidity levels where tomato puree meets sugar, vinegar, salt, and the mysterious spice blend. These rooms operate at exactly 68 degrees Fahrenheit, with 45% humidity to prevent ingredient degradation during mixing. Stainless steel tanks holding thousands of gallons of tomato puree await the addition of other ingredients in carefully measured proportions. The recipe consists of 72 to 75% concentrated tomatoes, 12% distilled vinegar, 10% natural cane sugar, and the remaining percentage includes salt and proprietary spice mixtures. Even tiny variations in ingredient ratios can alter taste profiles across millions of bottles, making precision absolutely critical during this phase. A difference of just 0.1% in sugar content can make ketchup noticeably sweeter or more acidic when multiplied across massive production runs. Quality control technicians weigh ingredients using scales accurate to within 0.01 grams, ensuring each batch matches exact specifications. Temperature fluctuations during ingredient addition can also affect how flavors bind together, requiring constant environmental monitoring. Automated mixing systems incorporate sensors that measure viscosity, pH levels, and flavor compounds in real time throughout the blending process. These sensors take readings every 30 seconds, feeding data to central computers that adjust mixing speeds and ingredient flow rates automatically. pH meters ensure acidity levels remain between 3.7 and 4.0, while viscosity sensors monitor thickness development as ingredients combine. Flavor compound detectors identify specific aromatic molecules that contribute to ketchup's distinctive taste profile. The multi-stage blending process adds ingredients in precise sequences over several hours to achieve perfect balance. Sugar gets added first and dissolved completely before vinegar introduction, preventing crystallization that could create texture problems. Salt comes next, followed by the secret spice blend that workers add manually despite the otherwise automated system. This human oversight ensures spice distribution meets exact standards that machines cannot replicate. The entire blending cycle takes approximately 4 hours from start to finish. Pasteurization tunnels expose the finished ketchup mixture to temperature zones reaching 185 degrees Fahrenheit for food safety. The ketchup travels through these tunnels on conveyor systems, spending exactly 15 minutes at peak temperature to eliminate harmful bacteria while preserving flavor integrity. Multiple temperature zones gradually heat and cool the product, preventing thermal shock that could separate ingredients or create off flavors. Cooling and final viscosity. Adjustments create ketchup's signature thick but pourable consistency after pasteurization. Specialized cooling chambers reduce temperature to 90 degrees Fahrenheit over 45 minutes while mixing continues. Technicians use devices called quantifiers to measure flow rates, ensuring ketchup moves at exactly 0.028 miles per hour or slower during testing. Batches exceeding this speed limit get rejected and reprocessed. Continuous taste testing protocols. Evaluate samples every 15 minutes during production using trained panels of flavor experts. These testers compare each sample against master standards, checking for proper sweetness, acidity balance, and spice intensity. Any deviation from approved taste profiles triggers immediate production adjustments or batch rejection. This combination of automation and traditional craftsmanship ensures identical taste worldwide, maintaining consistency across factories in different countries and climates. The perfected ketchup now races toward the final challenge, getting into bottles without losing quality. Creating consistent Heinz ketchup requires monitoring over 200 variables simultaneously across the entire production chain, from soil pH levels at partner farms to bottle fill weights on packaging lines. Temperature sensors, viscosity meters, and chemical analyzers work around the clock to maintain standards that have remained unchanged since Henry John Heinz introduced his tomato ketchup recipe in 1876. This hidden world of industrial precision explains why Heinz maintains its market dominance after 150 years of operation. The next time you squeeze ketchup onto your fries, remember the engineering marvel behind every familiar product you encounter daily.